Okay, are we ready to play a game? And the game is going to be Name the Alkynes. So let's see how many points you can rack up. And let me write down your first example. Remember though, I told you, as we go further in these videos, they might get a little trickier. So let's see what we've got in store. CH3, CH, double bond. CH, CH2, CH2, carbon, triple bond, CH. Now, let's pause it. I'm going to give you a shot at naming this alkene slash alkyne and see what you can give me as an answer. Then push play when you're finished. Okay, so let's see how good you did. I've got this longest carbon chain. That IUPAC rule never changes. So I at least know 1, 2, 3, 4, 5, 6, 7 carbons are at play. So hopefully I can at least write this down, hept, because that represents 7 carbons. However, notice how tricky this one is. Now, in the past, I've told you heptane, right? And I said, oh, look, we have a double bond. So we'll erase the A and we change that to an E. And then later on, I told you, oh, look, we have a triple bond. So we'll erase that ending and we'll change it to a Y. But guys, we've got both. A double bond and a triple bond. So does that mean that we kind of do this? That's wrong. You don't do that. Let me show you what you do though. We have to represent the presence of that double bond. We represent the presence of that double bond by putting the ENE there. All right. However, this also has a triple bond. So what we normally do is we erase this E. That's kind of the cap that puts an end to the name and we're not quite done. And then we now know that we have a triple bond, and that triple bond ends in YNE. Now there's the formal cap to that. And again, the E comes before the Y, and that's normally why we write it first. So this is a heptanone. The problem, though, is that we have to be very clear where the ene piece, which is the double bond, is located, and we have to be very clear of where the on piece is located, which is the triple bond. So these have to have numbers. Now, I'm going to look at this molecule, and we need to figure out how to number this system. I'm going to write both up on the molecule for you. 1, 2, 3, 4, 5, 6, 7. And then the other way, 1, 2, 3, 4, 5, 6, 7. Okay, what's the rule? That's the thing. We've never really seen an example like this before. Not a mix. And we have a mixture of double and triple. So how do we handle this type of situation? Well, here's the thing. Believe it or not, if you have a double and if you have a triple, we actually regard these as equals. Meaning that in the numbering of the main chain, it doesn't really matter here which one you give preference to. You treat them as equals and you still strive for the lowest numbers possible. That is what you do. This is a rule that has never went away in IUPAC, and it's not going to go away here. So, in other words, I will look at this molecule and I see that double bond. I do not give preference to that double bond. And I don't number closest to that side just because it's a double bond. I also will not look at the triple bond, and I will not give a preference to the triple bond either, just because it's a triple bond. I look at both of these at the same time, and then I tell myself, Tracy, which one is closest to the end? Because that's probably going to give me the lowest group number. If I go from left to right, I'm going to end up with a spot of number 2, because that's where the double bond would be, and a spot of 6, which is where the triple bond would be. If I go from right to left, I'm going to start off with spot number 1, and then on spot number 5. So if I look at my two versions, it looks like the version that goes right-handed to left gives me the lowest number possible. So that is why we choose that route to number the main chain with. All right? It doesn't matter if double and triple are on there both. You treat them as equals. Just imagine that they're two double bonds. Imagine that they're two triple bonds. How would you number it in that case? That is what we do here. So that means in the name, my on is going to happen at carbon 1. That is where my triple bond is at. So in this name at the very end, I do have to hyphenate it. I've kind of hinted to this before in the past. Hey, if you don't like to, put the number out here in front, then you can always hyphenate the endings, and that's acceptable. And this is where we have to, because the ene also has a number that follows with it. And the ene, or the double bond, is going to happen at carbon 5. So this is a 5-heptane 1-on. And that is how we write and say that name to that molecule. All right? So here was a chance where we got a mixture, but you now know you treat them as equals and just play the game like you've always done and give it overall lower group numbers. One does not prioritize over the other in the alkene/alkyne grouping. All right, so let's do another one. This time, let's do CH2, double bond, CH, CH2, CH2, carbon, triple bond, C, CH3. Let's name this one. Okay, using what we've just described, longest carbon chain, 1, 2, 3, 4, 5, 6, 7. All right, so we know this is a hept. I'm at least part of the way there. This double bond has to be represented with an ene. The triple bond has to be represented with an on. We can't just smush all of that together. We're going to have to separate them a little bit. So the en, we drop that e off because we're not yet finished, and then the yne happens after that. I've got to now give it number. What numbers go where? I treat this as equal, which means lower group number possible. And folks, the way that we get that is if we number closest to the left-hand side. 1, 2, 3, 4, 5, 6, 7. That is the order that we would number because that gives us lower group numbers for both the double bond and the triple bond. That's the whole reason that I did that. It wasn't because I'm giving priority to the double bond. In the last example, it was almost like we gave the priority to the triple bond. That is not what is the determinant factor here. It's lower group number. So at carbon 1, I have the double bond, so that goes with 1-heptane. And then at carbon number 5, that's where my triple bond shows up. Therefore, this is a 5-on, 1-heptane 5-on. Now, you are probably going to ask, is it okay then if I do hept 1 ene and then 5-on, or hept 1 n 5-on? The answer is yes, yes. Those are okay too. Whatever. It's okay. People do it a different way, multiple names to each molecule. That's perfectly fine. but you're going to see me and probably the textbook and probably Blackboard and probably on the assignments and the test it written this way: 1-heptan, 5-ine. All right, let's do another one. CH2, double bond. CH, CH, C, triple bond, C, CH3. And then off of this middle carbon, we'll put a group. And let's put a group of CH2, 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 CH3. And I ask you to name it. What would you give me? Well, this one's a little different too than what we've seen in the past. Not the fact that this is a double and triple bond. We now know how to handle that. Not a big deal. We just write them both down, separate them, and put the numbers with each one. Easy as that. But this one is the longest carbon chain. That's always the name of the game. The longest carbon chain that includes the triple bond. The longest carbon chain that includes the double bond. The longest carbon chain that includes maybe the OH if we're going to name it as the alcohol. That's always been the game. Doesn't change here. But what does modify is that you need to include the longest carbon chain that includes as many of the functional groups as possible. So that means if I begin to wrap around, because there is a longest carbon chain that happens here, I get bigger carbons right there, right? 1, 2, 3, 4, 5, 6, 7, 8 oct. That's an octa. Octyne, because there's a triple bond. Well, what on earth do we name this? Well, you might be smart and you might say, hey, I know, that looks very familiar to me because that carbon is double bonded to a carbon. Is that something like the vinyl group that we learned about in the alkene nomenclature? And you might be tempted to write that down as a name, but it's not really the proper IUPAC name. And the reason is because you've picked the longest carbon chain here that does not include all or as many of the functional groups as possible. And you are getting ready to write down that this is a triple bond and a double bond. And if you do that, you have to make sure that the triple bond and the double bond are included in the IUPAC name. But then you're going to say, well, wait a minute, we could name that as vinyl. We could call this an alkyne. You just said that there's multiple names that can go with each structure. There is. There is. And I'm not saying that that was wrong. But if we want it to be proper in the IUPAC rule, this is the proper IUPAC name. So that longest carbon chain includes the triple and the double. Because keep in mind, vinyl, allyl, all of those are common names. Isopropyl, sec-butyl, tert-butyl, isopentyl, isohexyl. Those are common terms that we use. They're not really recognized as far as IUPAC goes. So they're not proper. Well, sometimes we do it because there's really no other option. It's accepted to be okay. And here, we're being proper. IUPAC name, longest chain. It includes the double and the triple. It's perfectly okay. We'll still be able to name it without a problem. If I look at the longest carbon chain, 1, 2, 3, 4, 5, 6. So this is a hex. We have a double bond in play, so hexane. We also have a triple bond in play, so we know there's an ine. Each one needs a number. Well, if I look at these two groups, I treat them the same. A number closest to the end, that gives me the lowest number possible. And if I go left to right, like this, that will give me the lowest number possible. It gives me a 1 for the double bond, so 1 hexane. It gives me a 4 for the triple bond, so this is a 4 4-ine. And then at carbon 3, I see this group. That group is a 4-carbon chain. So at carbon 3, I have a butyl. 3-butyl, 1-hexane, 4-ine. That is the accepted IUPAC name for that molecule. Now, if you went the other way, just to prove a point, and you numbered right to left, look at your numbers that you would have ended up with. You would have had a 2 for the triple bond. Okay? You would have had a 4 for the butyl. And you would have had a 5 for the double bond. And if you look at that number set, 2, 4, 5 is higher than 1, 3, 4. So that is why we were forced to number from left to right in this case. Now, let's get a little trickier. Not tricky, just something that happens sometimes, and we just have to handle it. CH3, CH, double bond, CH, carbon, triple bond, C, CH3. Now, folks, sometimes this happens. It's just organic. It's the name of the game. Again, it is a game. It's just a set of rules that we have to follow. The reason that I'm bringing this one up, if you look at this particular molecule, you're going to go, hey, longest carbon chain. All right, 1, 2, 3, 4, 5, 6. This is a hex. And I would say, good job. You're on a good start. Keep going. Not quite done. And then we have a double bond, N. Then we have a triple bond, ine. Now we need numbers. Okay, so I'm going to number left to right. 1, 2, 3, 4, 5, 6. And then you might question it, and you'll say, well, what would happen if we go the other way? Because this is going to give me a 2 and a 4. Okay, well, if we number the other way, 1, 2, 3, 4, 5, 6. And this would give me a 2, and this would give me a 4. Well, wait a minute. If numbering left to right gives me a 2 and a 4 for the double and the triple, and then going from right to left gives me a 2 and a 4, going from triple and then double, can I just not use either one? I mean, can I use both? No, you can't use both. The reason is because IUPAC clearly defines the rule that has to be followed at this point in time. Right now, overall numbers is a tie. You're going to get a 2-4 one way, you're going to get a 2-4 the next way. The problem is which one gets the lower number? Which one gets the 2? Is it the double bond? Or is it the triple bond? Folks, if you keep remembering, I keep telling you that a bunch of PhDs sit at a table. They make up these rules that they want to follow. They put these rules in place and they say, all the scientific community has to follow these. And all of these PhDs got together, and common sense maybe would have told me that, well, I probably would want to give a triple bond priority because it doesn't really show up that often. You know, it's special. You want to make it feel special. And the way that we can make it feel special is if we give it the lower number. And these groups of PhDs said, no, I don't like that idea. I don't like it. No, we're not going to do that. What we're going to do is that if there's a tie like this, and I get the same numbers in both directions, meaning that there is a tie in which one gets the lower number. Is it the double or is it the triple? These PhDs have determined that a double beats out the triple every single time. Don't ask me why. I can't give you a reason for that. Maybe it's just simply because EN comes before YNE, so they just regard this as almost like alphabetizing. Maybe that's the case. But in any way, this molecule has to be, according to IUPAC, double bond and triple bond are tied in sets of numbers. Therefore, double gets priority. The accepted name is 2-hexane 4-ine, not the other way around. It's not going to be a 4-hexane 2-ine. And again, maybe think alphabetizing. Maybe that's the best way to look at this. They regard these as equals. We've seen that before. If they're regarded as equals, then the next thing that happens is alphabetizing a name. So E comes before Y, and maybe that's why they chose it to give a lower number instead. All right? Now let's do one more example of that one, just so that we can see it again on a different type of molecule. We'll do carbon with hydrogen, and we'll do a triple bond here. And we'll do carbon, and then CH2, CH2, CH, double bond, CH2. And we're expected to name this. All right, we got a mix, a double and a triple, not a big deal. I'll look at my longest carbon chain, 1, 2, 3, 4, 5, and 6 in total. So this is a hex. I know there's a double bond, and I know that there's a triple bond. So I can start there. Now I'll look at my numbering. Okay, so the number here, 1, 2, 3, 4, 5, and 6. So this gives me a 1 position, and this gives me a 5 position. That's where the triple and the double is located. Going the other route, 1, 2, 3, 4, 5, 6. At carbon 1 and at carbon 5. Oh, well, it's a tie again. Go figure. We just talked about 1, and guess what? We're doing another example of 1. So with this name, left to right or right to left, there's a tie. I get a 1-5 in one direction, and I get a 1-5 in the other direction. So by default, the preference is given to the double bond. Give that the lowest number. So at carbon 1, that is where my double bond is going to be located. And then at carbon 5, that is where the triple bond is going to be located. So 1-hexane 5-ine is going to be the name of that molecule. All right, let's do some more. This question just says name them. All right, so let's use what we have learned, and let's put this at play. But we're going to do this in the next video. So what I would like for you to do is write down A, B, C, D on a sheet of paper, pause it, draw the structures down, try and stab a name out of these things. See what you get. No one's going to be looking. No one's going to be peeping over your shoulder. No one's going to be slapping your hands if you get the wrong answer. No one will even know. But at least attempt them. Practice with them. So pause this video, write down these 4 structures, try and attempt a name out of each one of them. And then in the next video, we'll pick up from here, and we'll go through A, B, C, D, and we'll talk about how to name them, and we'll do a few more examples of the alkyne nomenclature. Good luck.